So this is the 2015 Junior Cert Higher Level Paper 2, and we're looking at question number 8. The diagram shows the triangle RST inscribed in the circle K. The line segment, RS, is the diameter of the circle. So we can see the circle K here, and the line segment RS going across the circle through the center, i.e. the diameter. Gavin says the size of the angle W must be 90 degrees. So this angle here, W, must be 90. Part A says, state one result on your course, a theorem or a corollary that shows that Gavin is correct. Okay, so what we're looking for here is either theorem 19 or corollary 3. And corollary 3 says that each angle on a semicircle must be a right angle, or must be 90 degrees. So that's the shortest theorem that would work, or that's the corollary rather that would work. Theorem 19 would also be sufficient. Part B, the line ST is 10 and the size of the line RS is 30. Using this information and trigonometry, find the size of the angle X. Give your answer in degrees, correct to 1 decimal place. Okay, so the angle X is marked here. So we're looking for this angle. We know the angle W is 90 degrees because of the theorem in part A, and the corollary. So we're dealing with a right angle triangle, and we're given the lengths TS was 10 and RT was 30. Sorry, RS was 30. RS was 30. So if we redraw that triangle over on the next page, we have just a sketch of it here. This side's 30, this side's 10. The angle here is 90, and we're looking for X. Okay, so because it's a right angle triangle and we're looking for the angle, we're going to use sin, cos, or tan, the trigonometric ratios. So I've taken these from the tables book down here. So we just have to match this carefully to our triangle here. So I'm going to do this using a highlighter. So we're looking for the angle X, which is the angle A down here. And on our diagram, we have the side opposite X straight across. So the side 10, now that matches the side A on the small a on the diagram in your tables book. Then we have the side 30, which is the side that's opposite the 90 degree angle. That's the hypotenuse. And in our diagram from the tables book, small c is the hypotenuse. So then we must look at the three trigonometric ratios and decide which one has small a and small c in it. And we can see there that it's sine, or sin a. So sin a is equal to a over c. So if we're just thinking of this in terms of positions now, that's what we're going to set up as our equation. So we're going to say the sin of x is equal to green over the blue, which is 10 over 30. So that's the equation set up. Well, if the sin of x is 10 over 30, then x will be the inverse sin. So you press shift sin on your calculator of the fraction 10 over 30. So remember, if we're looking for the angle, it's always shift sin cos or tan. And then we just put this in our calculator, and we get a value of 19.471, and on it goes. But we're asked to give our answer in degrees correct to 1 decimal place. So I'm going to look to the second digit after the decimal. Does this affect the number in front? well, it's 5 or more, it's the number 7, so yes, it does. So the angle X will be 19.5 degrees, correct, 1 decimal place. And that's the end of part B and the question.